Yes, sir.
Thank you. Good evening, everyone. Welcome to the third day of our International Faculty Development Program on high performance computing and data science applications. I hope you all have been finding the sessions insightful and enriching so far. Today, we have another exciting lineup of sessions that promise to deepen our understanding and spark new ideas in this cutting edge field. Let's continue this journey of learning and collaboration with same enthusiasm and curiosity. It is an absolute honor to introduce a distinguished personality in the field of computer science and engineering, Dr. S.B. Goel, sir. With a career spanning over 2 decades, Dr. Goel, sir, has not only witnessed but has actively shaped the technological advancements that are at the forefront of today's academic and industrial landscapes. Dr. Goel, sir, earned his PhD from Banastali University, Rajasthan, India in 2012, and since then he has dedicated himself to integrating Industry Revolution 4.0 technologies into higher education. His work in Malaysia have been particularly transformative, where he has seamlessly woven big data, data science, AI, blockchain, and cloud computing into the curricula of several leading universities. As a thought leader and pioneer, Dr. Goel's insight have been sought after at prestigious events such as Bloconomic 2019 and the World AI Show 2021, where he has shared his knowledge as a speaker. Additionally, he is a frequent panelist at various academic and industry forums where he discusses the latest developments in IR 4.0 technologies. Dr. Goel's contribution to the academic community extend beyond the classroom and the stage. He has made significant editorial contributions, serving as a reviewer, guest editor, and editor for numerous international journals and Scopus Index books published by globally renowned publishers like IEEE, InterScience, IGI Global, and Springer. His research, recognized globally, spans areas such as cybersecurity, IoT, and data mining. And his work has been extensively published in Scopus and Sky Index journals. As a senior member of IEEE since 2013, Goel Sir is also an inventor holding 7 international patents and copyrights from Australia and India. Sir's expertise and innovation has earned him multiple academic excellence awards, both internationally and nationally. Sorry. Currently, Goel Sir serves as the director of the Faculty of Information Technology at City University, Malaysia, where he continues to inspire the next generation of technologies and research. So, please join me in welcoming Dr. S.B. Goel Sir. Goel Sir, over to you, sir.
Thank you. Thank you very much. Is it audible?
Yes, yes, sir. Audible, sir. Please, sir.
So first of all, thanks to Vardhman College of Engineering, giving me the opportunity to interact with the audience, and a special initiative taken by the conveners, coordinators, and organizing committee, and a special thanks to the audience to spending the time from their too much hectic personal life. The time is there for the dinner, but unfortunately we are joining at this moment. So I'll try my best to enjoy the session is this. So let us start it. Let me share my slides. Just check it is not giving the right to me to share the slides.
Just a minute, sir. We are able to see, sir, now.
Okay. So let us start the session is there about challenges and opportunities HPC with data science. So it's very interesting topic is there. Let's take some audience little bit interactions. Any audience have any ideas there about HPC before this FDP? Anyone? Can we do the data science without HPC? Any audience say yes, no, something? Can we do data science without HPC? Or type in the chat box. Yes, no. Have we given the right to audience to type something?
Yes, sir. They'll reply in the chat, sir.
Okay, okay. Yes, anyone?
So
Chat is
they're
not
responding
visible.
in chat, sir. They're responding in chat. Some are saying yes, some are saying no.
No, actually chat is not visible to me.
Okay.
Have done some, I think, anyway, let's move forward because I have prepared some questionnaire on each and every slides almost. So it should be a little bit more interactive session rather than just only one-way communication. Okay, let us go ahead. So let us start. The flow presentation is there. We can start today from the introduction, some basic concepts of HPC as well as data science. Then we'll move forward skill development path. What are the skill set is required? Then we do some comparison of HPC and data science, as well as we need to work out what are the challenges, opportunity, what are the technical challenges, and what are the factors is there whenever we are doing data collection, data analysis is there in HPC as well as data science. What are the future trends in these areas, as well as how to collaborate, collaboration opportunities are available for HPC and data science, and followed by some case studies and followed by another some software tools is there. Let's do some basic discussions about how familiar are you with the concept of high performance computing and data science. You can see something is very familiar or not at all. If you are familiar, then what type of data science, what type of industries example you can quote? Somehow I am not able to see any chat responses. So what is the immediate term will come in our mind when we are talking about HPC? Any popular industry you can tell something is there about HPC, which is using more high performance computing concept? What are the tools you are aware about data science or HPC? Any tool name?
So they're saying the term as GPU,
Okay, great.
supercomputer,
Super,
faster
super.
computation, finance.
Excellent, excellent. Interesting. So what do you think the main difference between traditional computing and high performance computing? Any traditional computing, high performance computing, whenever we are comparing, can you just very small answer you can tell in one or two, three words? Any answer by audience?
I'm just saying, sir, no one answered. If the answer, I'll speak, sir. Uh, Participants, are you able to like access Q&A? So quantum computing, parallel computing, distributed computing, big data processing by HPC, all these terms they're writing, sir.
Okay, okay.
Goel sir,
So,
you are able to access Q&A section, sir. I'll ask them to use the Q&A instead of chat.
okay, okay. I have not done any, just actually on my screen, I am not able to see any chat also.
Q&A, sir.
No, I think you need to change the settings. Need to give the access to the presenter.
So you're already a presenter and you can get access, sir.
I don't know. It's
Oh,
not showing
just
to
you
me.
continue, sir. In the meantime, I'll check it once.
Okay, okay. Let us move forward. Is there? So let's start with cluster, node, and HPC architecture point of view. So fundamental thing is there, what are the multi-core processor, HPC node, and HPC cluster? How all these are correlated to each other. Multiple processor is called multi-core processor, collection of multi-core processor is called node, and collection of node is called cluster. In that context, we can talk about, and now you can list out some emerging technology that utilize the high performance computing. Audience can give us some answer quickly, which technologies are using the HPC. Data science is using HPC. Any another technology are using HPC? There are numerous technologies are available, like example, AI, ML, quantum, big data, genomics, climate modeling, autonomous vehicles, cybersecurity, VR, AR, pharmaceutical research, astrophysics, metaverse, data science, smart cities, blockchain, IoT, advanced material sciences, digital twins. So there is a range of technologies are there which are using the concept of HPC. So that means HPC play one important role in 2024. So let's see, and we can learn out quickly. So what this HPC is there? HPC we simply is called is use of supercomputers or parallel processing techniques to solve your complex computational problem. What do you mean by complex computational problem? Like real life example, we can consider climate modeling, genomics, or engineering simulations point of view, where is a high volume of data we are using. That purpose we can use the HPC. Other side, because when we are talking about HPC and data science together, other side we can say it, data science is a multidisciplinary field which can apply on any domain like financial technology or any other technologies. You can apply it, as well as you need to combine the domain expertise as well as programming skills and statistical knowledge to extract meaningful insight from your large volume of data. So correspondingly, there is some real life example we can say about data science we can apply on predictive maintenances. So already you know it, your industry is there. When your possibility of the breakdown of your machine is there, that advance in well in advance, you know it, or what type of breakdown will be happen in another 1 week, another 1 month. So that's a prediction you are doing it. Customer segmentations in retail industries is there. FMCG, a products point of view, we can apply, or healthcare analytics. We can do it, some appropriate healthcare analysis is there. So what is the possibility for the patient recovery? If similar type of treatment is we are giving starting from today, what is the possibility for the recovery after 1 month? What is the possibility of recovery in 2 months and 3 months? That we can do it, advanced analytics. So job prospects point of view, there is a like on the slide is mentioned, there is a different job prospects are available, HPC specialist, engineer, computational scientist, system administrator, parallel programmer, research scientist, or HPC architect. Similarly, in data science point of view. So let's see some key consideration is there for the conducting data science without high performance computing. Suppose we are doing data science without HPC, what are the challenges is there? That means we can solve these challenges with the help of HPC. So that's why this FDP topic come together where we are talking about HPC and data science. So fundamentally, there is an issue is facing we called is scalability. Whenever we want to do large scalability of projects is there, where is a data size is uh, very, very large, then corresponding, we are not able to apply data science. When there is a issue is coming about speed and efficiency is a major concern, like real-time analysis we are doing, like stock market, we want to do some uh, analysis. So correspondingly, speed and efficiency is a major issue. At this moment, if we are doing the data, we are applying the data science, that is useless. And but HPC can solve these issues there. Another side, we can see it about complexity of the analysis. When we are talking about complexity in terms of like whenever is the you want to do it more accuracy of the result in terms of particular time span. Time span is a limit which is called real time point of view. So correspondingly, traditional data science results are useless without HPC. Similarly, when we are talking about cost and accessibility point of view, so its cost effectiveness is missing in traditional data science, but when we are using HPC, then it become your cost effectiveness. So cloud computing as an alternative is there. So fundamentally, some extent cloud computing services offer scalable computing resources on demand. And rather than you are spending too much money on HPC because HPC become very, very expensive. So alternate solution is there. You can use the cloud computing and access the HPC resource using the cloud computing is there. So focus on the smaller as well as mid-sized projects is okay without HPC, but you want to focus on the large projects is there, big size projects. So without HPC is not possible. So what is a suggested configuration for HPC? And let's see how much memory, how much RAM we want to use it, how much type of processor we can use it, and what is the possible cost is there. Like this slide is indicating what is a specification is required for HPC. And here we have just mentioned the minimum configuration is there, whereas the definition is start about HPC, like CPU, GPU is mentioned, the detail is there, memory, storage, networking. So correspondingly network point of view, 200 Gbps is required. And correspondingly in the last column, you can see the appropriate cost range start from 25,000. So one node is there. And we are talking about minimum is recommended 10 nodes like we have shown in the architecture here. So minimum one node is there. And from the cluster point of view, we need the multiple nodes together. So that's why we are talking about here suggestions is a total of 10 nodes if we are considering it may be require more nodes is there. So correspondingly cost is mentioned in the dollar USD dollar storage system. You can see it where is a capacity 1 to 10 petabytes. 1 to 10 petabyte. That means HPC one major criteria is there. You need to identify if our data size is petabytes is there, then highly recommended is this. You use the concept of HPC. Networking point of view, interconnections, cooling and power point of view, you can see in the slide is there how much cooling is required, how much power supply is required. Operating system, fundamentally CentOS or Ubuntu or Red Hat Linux, as well as tools point of view. Major tool we use for HPC is there, TensorFlow, PyTorch, Spark, Hadoop, or any type of scheduler. We can use it, Slurm or PBS Pro. So we'll see all these tools also today itself. And overall costing, you can see it 650,000 US dollar to 1.4 million US dollar. So that's a specification and costing is projected in terms of basic HPC. So let's see some real life examples in data science that are typically not feasible without high performance computing. And due to their complexity as well as volume of data is involved, some real life examples we can see. If you apply the data science, you'll not get the appropriate results and not useful. These are the areas there where we call this climate modeling or weather predictions point of view, or genomics data analysis, large scale social networking analysis point of view, astronomical data processing, financial risk, or deep learning model is there, where is a uh, petabytes data you are using it, or particle physics simulations, automated drug discovery, or autonomous vehicle development, or real-time fraud detections in your e-commerce point of view. So fundamentally, all these broad areas there, if you apply data science without HPC, almost all efforts are useless because you are getting the very slow results and you are not getting the efficiently, and efficiency is missing in your results is there. So it's a highly recommended that you need to use any type of these type of real life example case study must use the concept of HPC. So why HPC in data science? So you need to handle large data sets, computational tasks, you can apply it, and enabling the advanced analytics and supporting the research innovations is there, where you can do it about data scientists to explore the complex problem and develop innovative solutions by providing the necessary computational structure is there. As well as when we are talking about computational tasks, that means there is a parallel processing is required. So that will allow your faster execution of the task, where we are applying the machine learning. So entire model can be trained and simulations point of view, which we can use for data collection, data analysis, and data interpretation point of view. So let's do some little bit self-assessment. Consider question number one. What is the primary purpose of high performance computing? Just audience can type A, B, C, D. What's the answer for question number one? And question number two, you can type for true and false. And question number three, again, you can type ABC. Let's do it quickly.
Goel sir, are you able to see chart now, sir?
No, it's not showing to me. I'm not able to see.
Okay, okay, sir.
Ma'am, you can share the result if you are able to see. Anyway, let's see what's the answer is there. So first one is B, to perform complex computational efficiency. Second one is false. Data science primarily focus on extracting the insight from the structured data only. No, we cover structured and as well as unstructured. Which is the field, which field typically use supercomputer to solve computational problem? Fundamentally, we use high performance computing. So let's see what is the workflow is there, AI workflow for high performance computing in data science. So there is some steps is there which can apply it. Someone have suggested 8 steps, someone have suggested 10 steps. Same 8 steps you can divide in 9 steps or 10 steps. But fundamentally it's 8 steps which can divide in 9 step or 10 steps. So step number one, when we are talking about the workflow point of view, data collection ingestion is there. There is we can collect the data from the various sources is there. It may be databases, IoT devices, or any type of sensor. Then Pre-process the data is there when we are talking about the like traditional pre-processing of the data. That means data cleaning, data normalization, and transformation we can apply it. And under this data collection, there is another step is there, which is called store the process data in HPC. Storage system is this. So in this way, this is a step number one. Next step goes for data preparation. When we are talking about data preparation, that means we are applying machine learning, data science. So partition the data in number of chunks, and that chunks should be provided. You need to give the training to your data is there, then data validation is required, and finally you need some testing is there for the authenticity of your data is there. Then you go for the next step is there, which is called about feature engineering. In feature engineering, we do it all relevant features depending on the problem statement is there, whatever we want to achieve based on the domain is there, and create the new feature is there, whatever you want to based on the objective you need to identify. Another thing is there when we are talking about data preparation, data augmentation is there, like for images or text data or video data is there. We need to find out what's the requirement is this. Another step we called is model selection as well as appropriate training is there. So here we need to learn about what are the existing models is there. That model can be support your deep learning or reinforcement learning or any another modeling method you want to apply, which we are normally study in your data mining. That can be selected here. And you need to apply based on all these models. You need to identify hyperparameters is theirs. And based on the hyperparameter, you need to train your model is there with the help of HPC infrastructure. And finally, you go for parallel processing or distributed training to speed up your processes. This. Next step is called model evaluation. When we are calling model evaluation is this, that means evaluate the model using validation of the data is there. That is the step number one. And adjust the model or hyperparameter based on the target we need to decide. And finally, test the final model on the test data set is there. Next is which called is model deployment. Whenever we're calling is deployment, that means deploy your trained model, which we have done in step number three. That trained model we can do it. And step number 5.2, which is mentioned, is monitor the model performance and accuracy. Here we do it adjustment, and if needed, again we'll go on step number three. Depends on what type of performance and accuracy we are predicting. So there is a recursive processes there, as well as you need to go it again, repeat step number two or step number three or step number one. And the next step after step number five, next step is there, inference and predictions is there. Like some research papers which are talking about they can define step number six in two steps. There is the inference and predictions as a separate step, then it will become 9 steps. So correspondingly, input the new data into the deployment model. Already we have given the training to your data model. Now we'll take the real life cases there at this moment, and correspondingly, we want to deploy the model is there, run predictions using HPC resources is there, and finally, you get your results in terms of particular relevant system or particular real life applications point of view. Similarly, step number 7, which we are talking about optimization and scaling, some researcher has suggesting that step number 7 can be divided in two parts, which is optimization, and another step number 8 can become scaling. So that's why I'm just saying that step number 8 or step number 9 or step number 10, that can be variations has come. Step number 8, which is very important thing, is their feedback loop and model update. That's a basic thing is their feedback loop. So model itself getting the training is there. So continuously collect the new data and feed into the system is there. Feedback system is this. So retrain the model periodically and the new data is there. So finally you get the implement feedback mechanism to improve the accuracy and performance. Like feedback, you are very used to nowadays is their large language model. Large language model is working based on your feedback loop is there. So the continuously, whatever you are asking the questions is there, whatever answers you are getting, whatever results you are getting, you need to give the feedback, and the correspondingly that accuracy will be improved if you are giving the proper feedback. Either you need to appreciate or either you need to criticize. So let's see what is the skill development path is there for HPC as well as data science, and let's see how we can support it. So what you need to know it about HPC is there. You have a basic understanding computer science principle as well as parallel processing and distributed concepts is there in HPC. And you must be very strong in C++ or Fortran. Recommended language is there C++. So that's the thing is there, like number of persons are talking about why we are studying C++ or Fortran still in 2024. If you want to become the HPC engineer, that point of view, still C++ is the right choice is there. But you want to do just only data science, Python or R is sufficient for that thing. So if you want to apply the data science with HPC, then you have the good skill set of C++ as well as Python is this. So we are able to give the justification to our student is there because number of student is doing the argument is there. Python is able to solve my problem. Yes, Python can solve your problem. But if you want to handle any HPC level projects is there, then still you need traditional programming languages there, which is C++ or whatever you want to use it. So you have still traditional method is there, which is the algorithm and data structure. Again, number of student is just saying that all algorithms and data structure is available in the Python in the ready-made library form is there. But still, if you want to handle the HPC, then you have the clear understanding which algorithm and which data structure you need to apply it. So awareness of HP system as well as architecture. When we are talking about architecture, that means nodes and multi-core processors or supercomputers, we should be aware about these things. But other side, when we are talking about data science point of view, which is in the third column, so familiarity tool like Jupyter, Pandas, TensorFlow is required. So if you are handling the data science with HPC, then you need the knowledge of traditional system as well as modern system together. So where to start as in learner is there. We can do the some courses on parallel computing and distributed system, as well as some little bit programming languages experience and Linux Unix experience is required. That is sufficient to kickstart your HPC is there. Another side, when we are talking about data science, we have mathematical strong foundation on statistics, mathematics, and programming languages, and focus on either Python or R with the real world data sets, how to handle it. So this is the path is there where we are starting about the skills point of view, as well as key skills to acquire. Once you have done your basic part is there on like where to start. After that, after the starting your thing is there, we need to move out about skill hands-on experience point of view on HPC as well as data science. Then there is a requirement is come which is called proficiency in parallel programming, MPI or Open MP, which is the name of the programming languages for parallel programming. Here understanding of HPC system, architecture that should be do it, what type of scheduling you want to do it. So job scheduler is there like Slurm, and knowledge of performance optimization techniques, we need to apply it. Similarly, some HPC tool is there, like example is CUDA or GPU computing is this. Another side, when we are talking about data science, then you need the concept of about Panda and NumPy, which is for data manipulation and analysis. Another side, we have the traditional machine learning algorithm, which is a decision tree and neural network. We need to apply it, as well as visualization tool is there, how we can visualize your final interpretation point of view. Matplotlib is there, or Seaborn or Tableau. Another side is there, we need to work out about traditional SQL and database management point of view. And finally, you should be have good skill set of big data, Hadoop or Spark is there. So finally, when to use these skills is there. You want to apply these skills whenever is traditional data science is failed to get your real life problem solved. That means without HPC, whatever project you are not satisfied with in terms of efficiency, effectiveness, speed point of view, then you need to start HPC is there, which already we have discussed. And you can apply this in the area of finance, healthcare, marketing, or social science. So whatever there is in multiple areas is there where you want to take any type of predictions or you want to take any type of informed decision making point of view, then you can apply it. Let's do some self-assessment on this. Which programming language is essential for parallel computing in HPC? True and false. And finally, which of the following is not typically key skills for HPC? Audience can give answer. Uh, Dr. Shanti, ma'am, please share the
Yes, sir.
audience
Yes, sir.
answer.
Yeah, I'll read out, sir. I'm waiting. C, for the first question, they are answering as C, sir.
Okay.
All the participants, please answer in the chat box, please. You write the question number also, please. All are responding for the question number 1 only, sir, as C.
Okay. Okay. No issue. So let's check your answer is there. Skill set. Let's move forward. So let's do this some comparison of high performance computing and data science. So we need to understand that what is the purpose behind this HPC. We are doing design to perform the complex computation and simultaneous quickly and efficiently, like parallel programming point of view. Simulations as well as quick and efficiency, we can do it, but data science, we are focusing on extracting the insight and knowledge from data through analysis and modeling. There is a one perception is there about data science. People are just only thinking data science, we are applying only extracting the insights from the data. Not only that, additional important part is there. We need get the knowledge from the data through the data analysis and as well as model designing. That is most important part of data science. So what is the similarity and what is the integration point of view we can think it in terms of similarity, in terms of purpose, both involve processing large volume of data as well as often requiring significant computational resources is this. When we integrate it together, that means HPC with data science, then HPC can provide the computational power which is needed to handle the large scale complex projects, whereas the traditional computing resources are not able to handle it, then this is the integration is required. When we are talking about key technologies for HPC, supercomputer, parallel computing, distributed computing, but in data science, which is required machine learning, statistical analysis, data mining, data visualizations is this. Primary users, as we have discussed, and data volume point of view, handle extremely large data set. Normally, it should be start with petabytes or more. So that's the one starting unit is there. You need to think out something you can say it, how much your data size is there. If someone is saying my data size is less than petabytes, then no point to use the concept of HPC. At least petabytes is a basic unit is there where you can start the concept of HPC. To deal with the large data set, which is usually smaller in comparison to HPC, which is data science just only using the concept of gigabyte or terabytes, but HPC using the concept of petabytes or greater than that. So this is a one basic parameter where we can use it. Another thing we can say it about computational demand point of view. So in terms of HPC, which is require computational resources, CPU, GPU, memory, and storage, high computational power resources is required. But in data science, less resources is required, which can be high for big data and deep learning tasks is there. So you can see integration point of view, data science algorithm can be parallelized and run on HPC clusters is there, where we are using the computational efficiency and speed of analysis. Like in terms of the research papers, when we are talking about 3-4 terminology, we can use in any type of research efficiency, effectiveness, or optimizations. So that if efficiency, effectiveness, optimization can be achieved using this computational demand when we are integrating HPC and data science together. Pick out any computing problem is there, where is the large data sets. Only you need to increase traditional, if suppose anyone have published any research paper in 2010 or 2012, where we have used very small data sets. Same paper, same model you can publish using the concept of data science and HPC. Same paper, almost same algorithm you need to revise and you can publish using the concept of HPC and data science. That model you need to little bit change and it is quite possible nowadays. So in terms of complexity point of view, we talk about involve complex simulations, numerical methods, as well as high-level mathematical modeling. But other side, when we are talking about data science, which is required pre-processing and statistical modeling and machine learning algorithms point of view. What is the final outcome we are expected from HPC and data science? In case of HPC, we are expecting that produce the simulations and predictions and analyze that aid in scientific research and engineering projects you can apply it. Engineering projects, we can choose out any projects is there like quantum computing or metaverse or blockchain, where is a large volume of data we are handling. In terms of data science, we can provide insights, prediction, actionable information, as well as for some decision-making processes there in multiple industries we can identify. Let's do some self-assessment based on this. What is a shared challenge between HPC and data science? What is a shared challenge, common challenge between HPC and data science, similarity point of view? Second one, HPC systems are more commonly used in real-time financial risk modeling than data science systems. And third one, which field typically handle the data sets in the petabyte range? Please type your answer quickly.
The second one is they're answering as true.
First,
First is C, second true.
okay. And third,
Third is C, sir. They're answering as C.
okay. So just check your answer. So let's see what are the challenges and opportunities in your HPC and data science. First, we'll discuss individual and then we'll come together. So what's who are the leaders there in this domain and who are the visionaries in HPC and data science together? What are the challenges and who are the which players is there? So let's see. In terms of leader is there resource management, efficient use and allocation of HPC resources. That's a major challenge is there, how to utilize your resources in terms of efficiency. Every organization is worried about like we can spend the lots of money, but do we have proper skill set? One. Second, they have the worries there, how much they'll be utilize it. That means number of hours per week, number of hours per month, how much utilization, percentage of resources utilization. That's a worry is there in terms of the leader's perspective. Scalability point of view, maintaining the performance with increasing data is there. So uh, like social media point of view, you want to do some social media analysis point of view, Facebook data or Instagram data point of view, you want to do some analysis, how to handle that scalability. That data size is increasing day by day, moment by moment, how to handle. So integration with the existing system, what should is the right approach is there? In terms of opportunities to handle the challenges, we can recommend something like innovation in AI ML, which is driving the new solutions is there. Where is a automation, you can do it rather than you do it manually. Once you have given the training of the model is there, then automatically can be do it. You can apply the concept of AI ML. So that's why in the workflow, we use the concept of AI. So that's why we have discussed this AI workflow, 9, 10 steps, which initially I have just only proposed 8 steps is there. So real-time data processing, which is we can use it faster decision making and advanced simulations for various fields can be a opportunities this. From the visionary point of view, what are the challenges is there? Complexity of algorithms. When we are talking about distributed system, when we are talking about parallel algorithm, then there is a complexity of algorithms is there, which is developing the complex algorithm, which is suitable for your traditional HPC. There is a lots of energy consumption is required, like we can apply this challenge, this HPC concept in your blockchain, metaverse area is there, that is required your high energy consumptions, which is addressing the high energy needs of HPC systems is there. Power consumption is too high. Integration of the new technologies, like we have seen it 17 broad areas there where we can apply the HPC, that emerging technologies that need to do it integrations. So in terms of when we are handling this type of challenges, we have the opportunities there. We can use next generation HPC. When we are talking about next generation HPC, that means we are talking about something is quantum computing concepts is there, parallel processing point of view. So cross-disciplinary application is there where is a maximum. So everyone can utilize it. So that's why nowadays is there pay per uses. People are just like some industry, some particular industry, every industry don't have the HPC is there. They have one HPC and they are sharing that resource with other industries also. So you need to pay per uses basis or projects basis is this. So they are using the shareable resources this. Another thing is there, which is called challengers. Who are the challengers in the terms of challenges? Adoption of the barriers is there. Who will be adopt in terms of industry master is there. So there is a resistance due to perceived complexity and the cost. Industries are not ready to adopt because there is a huge amount investment is required and complexity in terms of the manpower and utilizations point of view. In terms of legacy system, if you are not utilizing your hardware, which is very expensive, then it will become obsolete in another 2 year, 3 year, 5 years. So integrating with older system is there. So they are saying that rather than you completely buy the new system, we can extend existing system that can be utilized it. So what is the skill gap is there in terms of limited availability of the skilled professionals in the domain of HPC. But these challenges are opening some opportunities is there where industry partnerships is there. So multiple industries are doing the partnership. So they are sharing the resources together. Cost effectiveness model is there. So because it's a shareable resource, so correspondingly cost effectiveness is coming. And it's openly in terms of skill gap you can handle in terms of you can offer the particular educational program where is a training the future workshops can be a good ideas there. So in terms of Niche players is there where we are talking about limited resources. So difficulty investing in cutting edge technologies is this. Like we have discussed about 17 broad areas where the HPC can apply it. So difficulty investing in the cutting edge technologies is there. So either people are good in data science, or people are good in blockchain, or people are good in metaverse, or AI, or ML, but people are not able to handle different type of technological projects is there. Market competitions point of view, competing with the established players is there, and limited market reach is there. So how to handle these challenges? We have it open the multiple opportunities is there, which is called specialized applications, which is a focusing on niche area like personalized medicines, like treatment point of view, personalized medicine, or education point of view, personalized learning facilities can be open it. So customization, where is a offering and tailored appropriate solution, customization can be open it. So it may be system can open and suggest the runtime different questions for different students based on their learning skills point of view. How they are performing, how they are giving the answer, then correspondingly, particular X student, you'll get different questions. Y student, you get the different questions is there. So there is the emerging market is there, which can explore the entire new regions. Let's talk about more technical research challenges in high performance computing as well as in data science. When we are talking about technical research challenges, we are talking about in terms of research point of view. Like as the faculty development program is there, number of youngest want to join the PhD program, or they want to offer the some master projects in these areas. So fundamentally in their subject title is there, that can be, you can mention it, scalability, data volume point of view, or performance optimization, algorithm efficiency, or you want to mention about resource management where we are talking about computational resources, or you want to handle a particular problem, you can identify system architecture when we are talking about integration and interoperability point of view. So these play one important part is there from the researcher's point of view, technical research challenges. When we are talking about scalability and data volume, then correspondingly, that means we are talking about managing and processing extremely large data set HPC system. What are the challenges of HPC when we are giving the very, very huge data is there? But in terms of data science, handling and analyzing the big data efficiently in data science is there, or we can say it's something HPC scaling the climate model to predict weather changes is this. When we are talking about performance optimization, algorithm efficiency, that means we are talking about optimizing algorithm. And in terms of HPC, we can say optimizing the code for better performance on supercomputers using the optimizations algorithms is this. When we are talking about data science, that means we want to make a balance between model complexity and performance in your real-time projects. When we are talking about resource management, where we are talking about computational resources, resource utilizations. So fundamental challenges there, which in terms of HPC, how to manage the multiple jobs and how to manage the resources allocation in real time, and that resources can be switched over automatically one job to another job, and that can be handled by multiple nodes is there. That nodes make your cluster together. In terms of data science, we can utilize the efficiency use of the cloud computing resources for training the large models is this. So that's the one, uh, this resource management, carefully see the example is this when we are talking about HPC and data science. Here we are talking about data science point of view, cloud computing is sufficient, but when we are coming together, there is a HPC and data science, then cloud computing is okay, depends on the financial constraint. Otherwise, you need to use the concept of directly standalone concept of HPC. It totally based on what is a security, privacy, and efficiency is important for us. In terms of system architecture, integration, and interoperability, this is another research area is there where we are talking about to integrate HPC clusters with legacy systems is there. Rather than you are changing the existing resources completely, better you can add on particular one or two or three clusters is there in your existing system that can be help you rather than like I have suggested that minimum 9 nodes is required for the definition of HPC to meet out. Here we are saying you can use just only 3 to 4 nodes is there, which is sufficient with existing infrastructure point of view. So that's a mid-size approach is there where we can utilize existing resources rather than you can change the completely. So little bit you need to compromise with the results, but some extent you can get the solution. Another broad area is there where we are talking about research domain, which is the energy consumption or power efficiencies point of view. So challenges is there high energy consumption of supercomputing facilities is there. So you need to reduce energy uses in supercomputer centers. Other side, when we are talking about energy consumption, in terms of data science, we can say is energy efficiency algorithm in the data center is become major challenge. Traditional algorithm or traditional problem is there in terms of security and privacy, in terms of data protection, which is applicable for HPC as well as applicable for data science also. When we are talking about HPC, that means we need to secure sensitive information is there. So that's why we are applying the concept of in HPC, encrypting the data transmissions point of view. So encryption play one important role. Other side, when we are talking about security privacy, in terms of data science, we need to analyze large data sets. That point of view, we need to utilize anonymizing the data in healthcare analytics to protect patient privacy is there or depends on another financial domains. What are the outstandings is there? What are the collections thing is there? So complexity management in terms of management, system complexity, we need to identify in terms of HPC when we are talking about with many small component. When we are talking about small components is there, multi-core processors, node and clusters. So maintaining and troubleshooting a complex HPC environment is required excellent skill sets and person should be properly skillful is there, then only he can utilize it. Otherwise, it's not a resources utilizations is there. But another side, when we are talking about data science, which can integrate various machine learning model, uh, which are able to handle the complexity of integrating the multiple data science models. And finally, there is a come out which is called talent and expertise skills is there. So in terms of major challenges coming HPC, how to train new HPC system to the administrator as well as developers. Another side, data science point of view, how to upskill teams on advanced machine learning algorithms is there. So let's do some self-assessment, which is a key challenge in both HPC and data science. Second one, energy consumption is a significant concern in HPC system. And third one, which opportunity is driving new solutions in both HPC and data science? Let's give quick answer, whatever is the
Sir,
ABC or true false. Yes,
so
yes,
Goyal sir,
Dr.
they are mentioning the D option.
D option for question number 1 or question number 3?
Question number 1, sir.
Okay, perfect.
And for 3,
Very
they
good.
are mentioning as C, decreasing computing speeds.
And question number 2?
Question number 2, they are mentioning as true.
Okay. So question number 3, which approach is driving the new solution in both HPC and data science? So innovation in AI and ML play one important role, which provide like, so that's why we have mentioned is AI workflow in HPC and data science. Whenever we are talking about the challenges and solutions, so as per the research point of view, there is a one important factor is there. We should take care about ethical considerations in your traditional data science. What are the ethical considerations is important. So in terms of data collection play one important role, and in terms of ethical consideration, there is a concept is there which is called informed consent. So whenever you are collecting any data, like you are sending any survey form using Google form or any another monkey survey, you need to just mention it. We are storing this data for particular purpose. So you can't capture someone data without their consent is there. So that's why we are calling it ethical considerations, ensuring the individuals are aware and of agree to how their data will be collected and for what purpose you are using. You must give the assurance that you will not use this data for other purposes. And like obtaining the consent from the before collecting their personal data in a survey or any type of research study. Here play one important role is there, which in terms of data collection called is data privacy. So it's someone is confidentially, someone is sharing the health challenges, like you are doing some survey on cancer, you are doing some survey on AIDS, HIV virus point of view. So you need to protect the privacy of individual whose data is being collected, especially sensitive information. You can't share it. Someone identity number is there, or someone is citizenship or gender point of view. People don't want to share it. What is your gender? People don't want to share it. What is your religion or casteism? So correspondingly, but if you are collecting, you are mentioning that we want to do some like in India, there is a lots of thing is going about workboard analysis point of view. Sometimes you're getting the link is there on your WhatsApp, petition need to file it, changes in the constitution is there. So corresponding, you need to ensure that you are not accessing their personal information's point of view, or we must be ensuring anonymizations rather than you are asking some personal information. Without personal information, you are collecting the entire data. So that is another example is this. So you need to bias in data collection. That's another thing is there. Always we need to avoiding the biases in the way data is collected to ensure fairness and accuracy is there. We must be fair with each and everyone is there. It's not like that I am collecting the data with the university in terms of senior professors and junior level professors is this. So we are not doing any partiality in that sense. So ensuring diverse representation in the data set to avoid biased outcome in AI models. But it's always is a recommendation is there. Suppose you are collecting any feedback from faculty member who are the just only professors is there. You need to take the multiple variation, associate professor, assistant professor, or tutor is there. So corresponding you need to identify. So you have multiple range rather than particular target point of view. So correspondingly, you can't be biased in data collections. Another thing is there, ethical consideration is transparency is this. So being transparent about the purpose of the data collection and how it can be utilized it. So in the collection data collection form, you need to clearly mention it to the user how their data will be used in a particular type of product or particular type of services or particular type of decision making. You need to clearly mention and ensure that you are not misusing, you are not tomorrow you are not using for other purposes. Once you have done your data collection in terms of ethical considerations, we talk about data analysis. Whenever we do some data analysis, that should be mentioned it about fairness and non-discriminations point of view. That means ensuring the data analysis does not lead to discriminatory practices or biased outcome is there. You will not give the support like we want to take the feedback about university. So something data collection size is important. Data size is play one important is there. How many youngest lecturer is there? How many assistant professor or associate professor, and how many professors is there? That ratio should be more or less equalize it. Depends on the projects is there, what is the base value we are considering. So depending on the base value, avoiding the racial or gender bias in predictive analysis used for hiring your decisions is this. So that's why data integrity, which is called as something is like maintaining the accuracy and consistency of data throughout the analysis process is this. So continuously we need to validate the data is there, my data is valid or not. Once your data you are collecting, then do it some analysis, because sometimes it happen that people are not taking the reading is there. They directly click on A, B, C, or whatever option true, false you have given it. So sometimes some basic questions you need to ask it where you can check it that indicate that they are not taking the proper reading of the questions is this. So correspondingly, then in that case, your data entire survey is invalid. You need to give some very, very easy questions is there where you need to check out they have taken the proper reading of my survey or not. Accountability in terms of holding data scientists, which is a scientist which is accountable for the method and tools they are used in the analysis. So we have proper reports and we have the proper documentations where we are reviewing the methodology used in the data analysis for the transparency. And we have the justification why particular this model we are using, why particular algorithm we are using for the data analysis. So that should be a proper documentary evidence you should have, or avoid misleading uh, conclusion is there. So ensuring that data analysis is must be honest, unbiased, and not manipulated to produce the desired outcome. Sometimes nowadays challenges are coming in multiple papers. People are just mentioning the data is there and it's very hard to rely on that data validity point of view. Actually, they have done the data analysis or they have just produced the result using the LLM model is this. So that's play one important role, and data collection, data analysis is important factor in your ethical considerations. When you are using this data uses, then we need to come out ethical AI and automations point of view. Ethical AI, that means now when you are submitting the SCI paper is there on the journal, then they are asking it, have you used any uh, LLM model tools to submit this paper is there? Have you produced any section of LLM? They're asking that if you have used it, what is your intention is there, for what purpose you have used it, LLM tool is this. So correspondingly, you need to mention it for what purpose you have used it when you are submitting SCI paper on Springer platforms. So avoiding the biased algorithm in automated loan approval systems is this, that unfairly disadvantage certain group is there. So sometimes that's a thing is there. You can't do it all decision automatically, fully automatically is there. So that's why in case of biased algorithm in automated and loan approval system, you can't do it 100% in automation mode is there. Carefully before giving the decision, you need to check manually. So data sharing and accessibility and purpose of limitations and long-term impact play one important role in your data ethical considerations point of view. All these statement is required when you are submitting the paper in good SCI journals. Then they are asking about this ethical considerations we need to mention, and they are giving some checklist, and then corresponding you need to clear out. Let's do some self assessment in terms of ethical considerations. So what is the critical ethical considerations during the data collection? Transparency about data uses is a minor ethical issues in data science or is major? Which of the following helps ensure fairness in data analysis? Give answer quickly.
So they are Goyal sir.
Yes, please.
So they are mentioning first one as C, informed, consistent,
Okay.
and second one they are saying as a false,
Hmm,
and third one also they are saying as a C, avoiding bias in data collection.
that's good. Excellent. So let's come. What are the future trends is possible in HPC and data science? So in terms of like we are talking about, we need to utilize it. Quantum computing, AI integration in HPC, edge computing, hybrid computing environment, AI-driven simulators, and automated HPC system, blockchain integrations, or so many other things is there. So when we are talking about quantum computing in terms of HPC as well as data science point of view, we can say is because quantum computing has the potential to revolutionize the entire HPC data science by processing information and exponentially faster than your traditional computing point of view. So quantum computing play one excellent role in terms of HPC with data science. AI integration in HPC, why we are doing AI integration in HPC, already we have seen it. The 8 steps is there in AI workflow in HPC with data science. Here is a AI in HPC and data science is leading to more efficient system that can process and analyze vast amount of data autonomously. So that's a autonomous system one, and it's a automatic system is there. So that's why AI and machine learning play one important role in your HPC. Another thing is there in terms of cloud computing, which is the extension of which is called the edge computing. Then moving HPC resources closer to the data sources for real-time processing as well as decision making. Where we called is about is computing allow for decentralization data system is there. Like whenever we are talking about decentralization data system, we are very used to about blockchain. So we need to apply decentralization system is there, which is the reduce the final technical term. We can use it, reduce latency and bandwidth uses, which is crucial for your traditional IoT systems. Another side, when we are talking about hybrid computing environment, that means we are talking about the flexibility to scale resources whenever is needed. And we want to optimize the entire cost and efficiency in terms of HPC as well as data science. When we are talking about HPC, which can be combining the on-premises HPC systems is there with cloud-based resources for flexibility point of view. So HPC system can be accessed using the cloud computing. So that's why we are talking it hybrid computing. So we are using the concept of uh, dedicated on-premises HPC system, and that HPC system can be accessed using the cloud. So AI-driven simulations is there, which is the AI augmented simulation using AI to improve the accuracy and efficiency during the simulation process of HPC. And so that's why we are calling is AI driven simulations are becoming increasingly important in the like uh, advanced model is there where it is called as climate modeling, healthcare or financial forecasting or maintenance forecasting point of view. So automated HPC system, what do you mean by automated HPC system? That means self-managed HPC system. What do you mean by the self-managed? That means we are talking about developing the autonomous HPC system, which can be managed and optimized themselves. What do you mean by the optimize? Where we say resources utilization point of view. System have the capability to select like you have 10 clusters, but depending on the data size, depending on the performance, how many number of nodes and cluster can be utilized to solve this problem is there. It's not necessary that at a time you are utilizing the all nodes and cluster together. Depends on the data size, system have the capability to select the appropriate number of nodes and number of clusters is this. So when we are talking about blockchain integration, why, as we know it, blockchain provide the more securities there. Privacy and security can be achieved some extent using the blockchain integration. So that's why we are securing HPC framework workflows with blockchain is this. So here, when we are talking using blockchain, that means we to ensure that data integrity and security in your HPC system can be achieved. So that's why we are talking about blockchain is being integrated to enhance your security, transparency, and trust in data processing and management workflow. Because this is a characteristics of the blockchain technology. Some extent can be improve your efficiency, improve your security, transparency, and trust. But whenever you're using the concept of blockchain, little bit contradictory term is there. It reduce the efficiencies is this because lots of type of encryption process should be applied. So here is a matter is there how that's why it is required is HPC concept play one important role in the blockchain. So like number of researchers and sometime they are getting the questions by the reviewer is there in blockchain there is a efficiency is a issues there, so you can give the answer of that question is there, we can solve, we can handle using the concept of HPC using the nodes and clusters. There is some collaborative collaborations opportunities are available in high performance computing as well as in data science, where we called is something in the domain of healthcare and medicine or environmental science, financial and economics or engineering and manufacturing. When we are talking about this means that means we can handle any type of research funding projects is there in terms of genomic research where we can use the concept of collaboration between HPC and data science manpower experts is there. So whatever their rule is there, they can work together and do something where we can do it about so that's the impact is coming. What's the impact in HPC? What's the impact on data science? What type of example we can utilize? So in care, in terms of healthcare and medicine, we can accelerated drug discovery through the analysis of genomic data and simulation, we can do it. When we are talking about environmental science, immediately term will come in our mind is there about climate modeling is there. So that's the climate changes are coming. So climate modeling play one important role. Here we can do it. Climate experts is called climatologist and HPC expert as well as data science expert can together and handle the projects of environmental science. And they are able to accurate the climate changes predictions using HPC driven simulations and data analysis. There is a like very interesting research is there in terms of environmental science and climate modeling. There is a prediction is there about by 2034 or 36, between 34 36, South Africa portion will be cut down and that will be hit your entire soil. That portion will become and touch with the uh, Indian part is there about Bombay, and Bombay can be convert like Ladakh. That type of environmental changes is coming, and there is a prediction is there it will be happen by 2034 and 36. Financial and economics point of view, there is a risk analysis can be do it in terms of collaboration, financial analysis, the HPC or data science professionals, where they are able to handle type of real-time risk management systems uh, in terms of financial forecasting, decision-making process. Another area domain is there, which is called engineering and manufacturing. These persons can also collaborate between engineers, HPC expert, and data scientists together, and they are able to handle different type of simulations, crash test for automotive design using HPC, which is analyzing your result for safety improvements point of view. Another area where we called is some possibility for the collaborations. We can do collaboration between in the area of social sciences. There is a social sciences expert is called sociologist, HPC, and data science expert. Here we can do it using HPC to analyze social media data sets to predict social movement or public opinion trends is there. Like at this moment, there is a movement is going on. Ukraine and Russia are fighting. Ukraine, Russia, another side is Bangladesh dispute is going on. Everyone is giving the views on Bangladesh perspective. So correspondingly, what is the social reactions are coming and what is the predictions about that social movement and what is the public opinion trends are coming, who is right, who is wrong, and who is behind of this Bangladesh fight is there, who is giving the funding in terms of Bangladesh fight. So education and learning domain is also there when we are talking about education and learning. Like at this moment, I'm giving the questions to all audiences, the same questions. But if it is a personalized learning and based on the individual student giving different answers is there, based on their individual levels is this, next question should be displayed based on their existing level. So that's a personalized learning, collaboration between educators, HPC expert, and data sciences. Here we can say is adaptive learning or personalized learning is the platform that customize educational content based on the student performances or student responses. Another area is there which is called as public policy and governance point of view. When we are talking about public policy and governance domain is there, that means we need to come out collaborations with policymakers, like policymakers, what are the changes is required, Indian to handle any type of religion fights is there, where we are talking about Hindu and Muslim point of view, how to handle this, what are the so corresponding simulating the effects of economic policies on employment rates using HPC and data science, like there is a lots of debate is going on how much GST should be appropriated. Whenever is a one real life person is buying any bike is there in India, 28% GST is there. Whenever is a someone is purchasing the aeroplane, then just only 5% GST is this. So what are the public opinion, what are the public policies and governance structure should be do it that can be do it in this domain. Another side, when we are talking about cyber security, as we know it's cyber security point of view, what are the threats is there in your and that's why it's open the opportunities there for the cybersecurity expert, HPC, and data scientists, and they are able to handle collectively real-time detections of the cybersecurity threats, where we can utilize the HPC as well as networking skills is there. Let's do one case study, successful projects in HPC and data science. Let's take a quick concern is there about climate modeling and predictions point of view. So what type of project is this? Climate modeling, definitely we use the concept of HPC. Climate modeling, you can't handle like column number 3, which is called case study type. Here we have mentioned it. This is the project of HPC. Or this is a project of HPC and data science or data science or HPC and data science. Climate modeling and predictions, because we are using the concept of climate modeling and prediction, like here, answer can be come out HPC as well as data science or HPC. It depends on what type of objective we are using in terms of climate modeling. So utilize the high performance computing, which can simulate and predict the future climate scenario by modeling interactions between atmosphere, oceans, land surface, and sea ice. So if we don't want to apply the AI or ML model training, then no use of data science for the climate modeling. But if there is the objective is there, we want to develop the particular train the model is there, and which can be automate the future processes there, then same case study can be converted in HPC as well as data science together. But other side, when we are talking about project like human genome projects is there, that means genomics healthcare point of view, genetic point of view, any type of genetic disease analysis we want to do it, like genetic analysis, you want to do it about Parkinson disease, that Parkinson disease analysis, then the correspondingly HPC and data science play one important role together for the personalized medicines, improving the treatment outcome, reducing side effects by tailoring the treatment to individual genetic profiles is there. Another side, when we are talking about predictive maintenance in manufacturing, so just we are talking about machinery point of view. Here, HPC, there is no point. Directly, you can handle this problem using the concept of data science. Here, we can, what is the final outcome is there. We can reduce the downtime, save the cost is there, increase the efficiency by allowing proactive maintenance point of view. Another area is there which is called financial risk management. Financial risk management, that means finance and economics. And here also there is a requirement is there. We need to work together, HPC as well as data science together, which able to handle more informed decision making. So whenever you're taking the particular decision, you have the proper evidences and logical explanation why we are taking this particular decision is there, why we reduce the financial exposure is there, and why we are improving the regulatory compliance point of view. So you have proper justifications. Data science giving the entire justification is there, is your approach is wrong or right. You do some analytical report is there using data science is this. Another thing is there like project is drug discovery and development point of view. So if you are writing any research paper is this, you can mention any case study. Same paper you can same paper you can publish with different case studies is there. Where is it? You need to change the objectives, then correspondingly that model can be changed out and you'll get another one um, SEI paper level. So if someone is guiding the PhD students is there, it may be choose out one domain is there, HPC and data science, and select particular different projects and different objectives. So in the same area, you can get the multiple papers. It will be easy for students and it will be easy for supervisors. So you can accelerate the development of the new treatments and reducing the time to market and lowering the cost of this. So this type of research can be useful for not fundamental research, but can be used for incremental research point of view. This the time is there for the self-assessment. Let's talk about the question number 1. Which of the following domain utilize the HPC to simulate and predict future climate changes? Genomics, finance, environmental science, manufacturing engineering. Second one, what was the primary impact of human genome projects case study that combine HPC and data science? And third one, in which case study did data science help in reducing the downtime and saving the cost by predicting equipment failures?
Goel sir, they are
Yes.
answering for first question as a environmental science,
Okay.
and second one as a D, paved the way for personalized medicine.
Okay. And third one.
Still, participants are trying to get the answer. The typing for the third one.
Okay.
For third one,
Excellent.
they are saying as a B, sir, like predictive maintenance in manufacturing.
Perfect. Perfect. Excellent. Let's talk about some tools is there which can be used for HPC as well as different tools for data science. And when we are handling the HPC and data science together, then we need the combination of HPC tools as well as data science tools together. Like in this table, we are mentioning the tool name, domain is like HPC or data science, and we are talking about who are the developer for this, what's the purpose, and what's a key feature, and some example of the small use cases is this. Like tool name, first one is very popular in HPC Slurm, which is developer is Shade MD. We are using for the job scheduling and workload management. On this tools, there is some questions is there, so carefully little bit focus. For what purpose, which tool? Slurm is very popular tool in HPC. So example, managing and scheduling the job on large HPC cluster to optimize the resources, uses and minimize your downtime. So with the help of this, we can enhance your downtime. Uh, we can reduce your time. We can reduce your downtime. So OpenMP is another popular tool is there, which is developed by OpenMP Architecture Review Board, ARB. Developer name here we can utilize for parallel programming framework. Depends on what type of resources and objectives we have. Based on that objective, we can decide appropriate HPC tool. So we have the range of tools is there, but here for the sampling, we are showing very few. So simplifies parallelization of the code and supports multi-platform, shared memory, and multi-processing point of view. Here, like example, we can say it accelerates the scientific simulations by parallelizing the computational across multiple CPU cores is there. Another excellent category tool of HPC, which is called CUDA, and there is a developer is there, Nvidia, which can be utilized for GPU programming and for parallel processing cases there. Here we can utilize it about deep learning models. If you have lots of graphics, videos, and photographs, can we use it running deep learning model on GPUs to significantly speed up the entire training model processes this. In terms of data science, there is a tool is there which is called Apache Hadoop, and which we are all of us very popular about Apache Hadoop point of view. So developer name is there, Apache Software Foundations, and we are using for the purpose to handle the big data processing and storage point of view. Here we can analyze massive data sets in a distributed environment for insight into customer behavior predictions. Can we use it easily in case of data science tool? Another popular, maximum popular tool is there about data science, which is called TensorFlow. Here, this tool is developed by the Google Brain team. There is another sister concern of Google, which is called Google Brain team. And here you can use it for the purpose of machine learning and deep learning projects. And you get the entire support is there when you have multiple hardware infrastructure is there at multiple locations. So you are taking some hardware infrastructure resources from India and some resources you are taking from USA using the cloud technologies. This so TensorFlow is can be utilized it where the CPU, GPU, TPU can be utilized it. So developing, deploying deep learning model for image and speech recognition system point of view. And another popular tool is there which is called Jupyter Notebook point of view. So there is a project can be identified in terms of interactive data analysis which can be allowed for live coding and equations visualization point of view. So these are the some popular tools are available for HPC and data science. Let's do one real life of case study where we need to apply these initial 8 steps we have mentioned it. Let's take a quick reading to understand the case study is this. All of you take a quick reading about what is the scenario and what is the problem statement. Then we can apply 8 steps on this case study. All of you take quick reading of the scenario and problem statement. Do your analysis in your mind, then apply it. At least understand the problem first. Then we can discuss the number of steps, or it may be after the session, you can do it Do we need more time or we should move forward? I think is a sufficient time. Let's move forward. Fundamental thing is there. We need to understand this context. We need to understand the problem statement. In problem statement, there is a condition is giving, temperature is changing, precipitation patterns are changing, or extreme weather events is there. Suddenly you find that lots of storm is coming or lots of extreme temperature is high. Then what are the challenges to create a high resolution climate model that can run within a feasible time frame and making use of latest advancement in data science HPC? How to apply data science, how to apply HPC with data science to handle and develop the climate model is this. This the entire thing is required. And already we have done the analysis is this. These are the 8 steps is there. Actually, there is a time shortage is there. Otherwise, we need to pick out and we can apply one by one all these steps. So which would take around 40-45 minutes, but is well defined all steps. Pick out your data and correspondingly apply these steps one by one. So it may be a good exercise for the every participants to learn these things, to apply these 8 steps one by one. And what are the outputs is there? Here, based on this case study, and you want to develop the high resolution climate model, you can select and you can apply like data collection, ingestion, all steps you can apply climate model development, model training, simulations, how we are doing, apply everything. Finally, you need to measure the final outcome. What are the lessons learned from this case study? So finally, computational power enable the precision, interdisciplinary approach, and continuous improvement can be continued processes this. You need to think out about all those things and do some analysis yourself. So some basic self-assessment in terms of key benefit of integrating HPC and data science. What is the benefit if we are integrating HPC with data science? What is the major challenge in deploying AI-driven solution in HPC environments? We are almost towards the concluding the session. To give answer quickly, question number 3, which industry has significantly benefit from combination of HPC and data science? Like industries, retail, manufacturing, finance, agriculture. What is an ethical consideration when handling large data sets in data science? And question number 5, which of the following tools is commonly used for job scheduling in in HPC environment? All of you give
So
quick
the
answer.
first, yes,
Yes.
sorry to interrupt, sir. So the first one they are saying as a B option, that is faster
Be faster
processing
processing.
larger data sets. And for second one, they are saying as a C, high energy consumption. And still, I think they are giving the answers. Like for third, they are saying as a finance.
Okay. Question number 4 and 5.
And fifth one, they are saying as a D option, that is TensorFlow. And fourth one, they are saying as a B, data anonymization.
Key fundamentally that tool point of view, all remaining answer is okay. Just question number 5. Job scheduling, we want to use it about Slurm. So let's come towards final conclusion session is there where we are talking about so convergence of HPC and data science bring both significant challenges and as well as excellent opportunities is there. There is a collaborations we can do it, we can solve real life problems is there, and major challenges coming continuously growing data demands which can increase your complexities computational problem with the heighten the need for advanced HPC system and sophisticated data science modeling and algorithms. We need to equip ourselves with the right skill set and embracing the emerging technologies like AI and quantum computing. And we must be fostering interdisciplinary collaborations which enable us to fully harness and potential of HPC and data science. By doing so, we can drive innovative that only not only address the today's challenges, but it should be ready for the future upcoming challenges together. So we need to encourage to explore transformating power for HPC data science in your real life work, real research work, as well as industries. There's a lots of potential is available where you can do it uh, research in this area is there. I can share it, hold it. There is a journal is there which is called is Computing and Informatics. Computing and Informatics. There is a special issue is available on HPC. Uh, I am editor for that journal. The SCI journal is there. Computing and Informatics. This submission is open yesterday. So if anybody want to submit the SCI paper in the area of HPC, most welcome. So finally, let's discuss about takeaway, which is called HPC and data science together, which can forces driving innovation across critical industries, as well as you can apply on different fields, solving the entire complex problem, or you can do it about any predicting the climate changes or personalize the medical treatment or personalize education systems point of view. So there is a complete intersections overlapping between HPC and data science together, which can provide the unique opportunities to tackle the challenges at scaling point of view. And by understanding the challenges and utilizing the right tools and collaborations, we can expand the entire boundaries, what we can achieve together. So lots of collaborations opportunities are there where you can do it about do collaboration with supply chain industry. You can do collaboration with finance. You can do collaboration with the educationalist, or you can do the collaboration with drugs, pharmaceutical companies is this. So finally, we are getting the fast result, more accuracy and efficiency, effectiveness can be increased. So overall, I can say I'm open for any type of questions, collaborations. We can do connect for any type of collaboration, joint research, whatever you want to do it. I'm open for everyone. And let's hand over to coordinator. If any audience have any queries, doubts, we can discuss it. Any doubt, query?
Participants, if you have any questions, you can ask.
Or otherwise, you can send me the email or send me the messages. If you have any doubt is there, you want to connect later, is okay. I can understand it's too late. Maybe people are waiting for the dinner.
So, Goel sir,
Yes, please.
so one query they have mentioned like, what are the courses are there for this HPC to learn?
Already, as I have mentioned in the skill set, there is a distributed system parallel programming is play one important role, and programming languages play one important role. You can start with the in terms of data distributed system, parallel programming, and distributed database, and C++. On this slide, I have covered this C++, parallel computing, and basics of computer science, algorithm data structures, and parallel computing, programming languages, and Linux operating system point of view. These are the basic skills. Once you reach basic skill, then you can move to another parallel programming, which is called MPI or OpenMP, as well as you need to explore the advanced tool is there, where is Slurm or advanced tool, anything depends on the requirement. GPU computing or CUDA, you can utilize it. Cluster nodes play another important thing. I hope I have covered the basic essential requirements. Any other query?
No queries, sir, but Dr. Bora is saying, thank you for the wonderful information shared.
My
And we
pleasure.
have one question. To publish in journal, how much time to get index?
It depends on the publishers is there. It may be index on 3 days or it may be index in 3 months. Because it's depend on the publisher. When they compile the entire data is there and they are sending to the elsewhere. So all journals indexing can be done by the elsewhere. And all journal make it compile the report and sending to the elsewhere. It depends on the which cycle they are sending the data to the elsewhere. So that's why this time variation is there. It may be 3 days or it may be 3 months, but maximum it take 3 months. Normally it can be possible 10, 15 days, 1 month, but extent time is 3 months. Is the HPC special issue is available. HPC and HPC special issue is available. Journal name is Computing and Informatics, which is a focus on re-imaging the future transformative approaches in high performance distributed computing. And this journal is submission is open on
So how
submission
much
is
time it
open.
will take, sir?
Ma'am, always is a publisher. This publisher is a little bit slow, but maybe if you submit now, then can be published by around end of August, September of 2025.
Okay, okay. Thank you, sir.
Normally 3 round of revision is there.
Okay, okay. I think, sir, there is no further questions. Ganesh, sir?
Yeah, madam. Yeah. Okay, madam. Yeah. So thank you, sir. As we draw this enlightening session to a close, I want to extend our deepest gratitude to Dr. S.B. Goel, sir, for his invaluable insights today. Sir, your profound knowledge and expertise in high performance computing and data science have not only enriched our understanding, but have also illuminated the challenges and opportunities that lie ahead in this dynamic field, sir. Sir, your ability to bridge the gap between cutting edge technology and its practical application in academia and industry has provided us with a clear path forward. Your presentation today has given us the tools and perspective we need to better integrate these advanced technologies into our curriculum, research, and development efforts. On behalf of everyone present, I would like to thank you for taking the time to share your wisdom and experience with us, sir. Your contribution have undoubtedly sparked new ideas and approaches that we will carry forward in our work, sir. Once again, thank you, Dr. Goel, sir, for your inspiring words and for being a guiding light in the ever-evolving landscape of high-performance computing and data science. Thank you, sir. Now, I would like to invite Dr. Shanti Makka, madam, to brief the participants about tomorrow's session.
Am I audible, sir?
Yes, madam.
Uh, Dear participants, tomorrow we have Mr. Swapnil Saurav, Manager Problem Management from ServiceNow Hyderabad. And he's having around 26 years of experience, and complete all experience is from the industry only. So he's going to like complete 2 hours. He's going to give us the hands-on sessions using Python. So guys, please be on time, and he will be discussing all the algorithms relevant to the machine learning and artificial intelligence. Please join us on time. Thank you very much, and kindly fill the feedback link. Yesterday, so many participants texted us like they are not able to fill the form, and the link is open till 9 p.m. Kindly fill the feedback link also. Once again, Goel sir, thank you so much, sir, for accepting our invitation.
Thanks, Dr. Shanti Makka, for giving the opportunity. Thanks, Dr. Ganesh. And thanks to all
Thank you,
organizer
sir.
committee.
Thank you, sir. Thank you so much. Good night, sir.
Thank you, sir. Thank you.
Good night. Good night.
Participants, you can leave the meet.